Okay, thank you, Seth. All right. Okay, so we're gonna do chapter 5 review today. Um, ouch. The chapter 5 review is very similar to the chapter 5 exam. There are 9 questions on the review. There are 9 questions on the test. Very, very similar. If you can do the review, then you will be able to do the test. Okay. Okay, so let's get started. Find the volume under the graph of Z. Okay, so we're going to find the volume. I cannot tell you if the order will end up being the same for everybody. So I guess that's the only thing that might change. Equal to 2x squared plus 6y squared. And over the given rectangular region 0 to 2, 0 to 1. Okay, so what you also need to know is that it says give an exact answer, use symbolic notation and fractions were needed. So in other words, they don't want decimals. However, if you should forget that and you type in a decimal and it is equivalent, I will give you the points because I really don't feel like that's an issue. So the first thing you would want to do is you would want to draw your picture or have yourself an idea. Let me see if I can pull this up and add the pictures in as we go. Okay, so this is going to be what the picture looks like. Okay, so that's what we're looking at. So since z equals f of xy is continuous, and z is greater than 0 over the region the volume V under the surface would be found as V R f of xy dA. Okay, so if we use Fubini's theorem, we want to replace the double integral to the integrated integral. Iterated. That's not a hard word for a math person to say. Oops. And then so then your volume is going to be 28/3. And luckily, you don't have to worry about units. So we are done with that one. I'm going to give you guys a few minutes in case you need to write it out. Okay. All right, so we want to, this one is saying use double integration to find the area of the region enclosed by the graphs y equals x squared minus 64 and y equals 64 minus x squared. Again, they want the fraction, not not the decimal. So let's take a look at what that looks like. All right, so if we say then that h of x and g of x, okay. All right, observe that the given region R is x simple. It is bounded by the graphs that you see there between x equal to -8 and x equal to +8. The upper bound for x is given by solving the equation x squared minus 64 equals 64 minus x squared. Find the area A of the region R using Fubini's theorem for x simple regions. So we would have A equals R dA, so -8 to 8, and then from x squared minus 64 to 64 minus x squared dy dx. Okay. What I can tell you is that I was nice and I tried to give you guys the longer problems on the review and the in terms of length, like time. So hopefully you guys will be feeling confident on the regular exam. Sorry, I'm just waiting for this one to load the whole way. There it goes. Okay. All right. So this one says express the integral as an iterated integral using polar coordinates if R is the region enclosed by y equals square root of 4 minus x squared, and the lines y equals x and y equals negative x. All right, again, we're giving the exact answers, use symbolic notation and fractions where needed. So next we're given r x squared plus y squared dA equals theta 1, theta 2, r1, r2, f r theta, dr, d theta. Right, so that is given information. And what we're looking at here in terms of your imagery okay, so that's kind of what we're looking at. So we want to use the theorem of iterated double integral in polar coordinates. The function is continuous over the closed bounded region. So what does that tell us? That tells us that in polar coordinates, the region R is enclosed by this, and this, and this. And so what does that mean to us? That means that we're going to have an R from 0 to 2, and theta will be pi over 4 to 3 pi over 4. Okay, and you should get that from basically the image. All right, so the next step we would take is okay, so the answer they want is just f of r theta, which is r cubed. So this is the answer you would put in the box for f of r cubed, or for f of r comma theta. For your thetas, you would do theta 1 is pi over 4, and theta 2 is 3 pi over 4. Okay. Should they have asked you for your r's, you would have had r equal to 0 and r equal to 2. You will want to know how to find both. I can't remember how the test is, if the test asks for theta or if it asks for r. So you'll want to know how to do both. Okay. All right. Yeah, we'll leave it with the green. All right, so the next one says, consider the homogeneous lemma, sure, of mass density rho enclosed by the lines 3x plus 4y equals 12, x equals 0, and y equals 0. And we want to find the mass m of the okay. So the region R is enclosed by the lines. So R is a right triangle. The first leg is 3 units. So, and then the second leg is 4 units. So you guys all should be able to kind of have an idea of what that looks like in your head, but I will be nice and I will bring it on over to the side just for the sake of completion. Okay. All right. Okay, since the region is homogeneous, the mass density is constant. Okay. So that tells us that M is equal to rho times A, which is 1/2 3 times 4 rho, which is 6 rho. We have multiple questions up here. I think we do. We do. Yes, we have to find MA, or M, which we just did. So that's your first fill-in. Okay, the second fill-in, you're finding the moment of inertia about the y-axis. So okay, so let's oh, please tell me it did not change. Cool. Yeah, it changed. That's annoying. Sorry guys, I got out of it and now it's gonna just keep changing. Ah, here we go. Back to it again. Oh, it's nice to know there's only like 3 of those options. Okay, so to find I sub y, or your inertia about the y-axis, we may end up needing another slide for this. I feel like I say that all the time to you guys, so it should be old hat at this point. Okay, so actually the third one is a little bit shorter, so I'm just going to squeeze it in. So the radius, the last question asked to find the radius of gyration of the mass about the y-axis. So that's where you find k sub x, which is the square root of the inertia about the y-axis divided by the mass. which is why you need the first two. And that is equal to 2 square root of 2/3. And that is one that you're not going to want to try to give a decimal answer to. So this would be kind of like part A. So part A answer, part B answer, part C, and part C answer. All right. Guys, ready for the next one, hopefully? What are we on? Should be on 5 then. Okay. Moving right along. Find the surface area of the part of the surface z equals xy in the first octant that lies within the cylinder x squared plus y squared equals 9. Again, enter the exact answer. Let me show you what these two images look like. So the idea here is that in part A, or, figure A, it says the part of the surface Z f of xy equals xy that lies in the first octant within the cylinder x squared plus y squared equals 9 is shown in the figure A. It lies over the region R in the xy plane that is bounded by the circle x squared plus y squared equals 9, and the coordinate axes of the first quadrant are shown in figure B. The partial derivatives of z equals xy are y and x. Let me have that in for you so if you can show your partials. So z is equal to fxy, which is equal to xy. So then you would have fxxy equal to y, and fyxy equal to x. So those are the partials. Since both partials are continuous on the surface, on R, the surface area S is going to be found by a really disgusting looking formula, but you guys can handle it. So okay, since the region R is bounded by part of a circle, we want to use polar coordinates. In the polar coordinates, R is given by, so if we are looking at polar coordinates, and we would have r is between 0 and 3, and theta is going to be between 0 and pi over 2. Also, the identity r squared equals x squared plus y squared. To transform the integrand, then the integral becomes, so this part up top here, gonna go a little bit Christmas. 0 to pi over 2, 0 to 3, and it's just gonna be the square root of r squared plus 1 d, r dr d theta. Then to evaluate the integral, we want to use a u substitution of r squared plus 1. So then du would be 2r dr. So then r dr equals 1/2 du. We would also change the limits. If r equals 0, then u would equal 1, right? 0 squared plus 1 is 1. If r equals 3, then u equals 10. Same thing, 3 squared plus 1, so 10. So now we would evaluate the integral. This integral over here. We haven't taken well, right, but we haven't done anything with the square root yet. Like we're still, so let me, your question might get answered as we keep working it. So we're going to switch this to 1 to 10, square root of u, 1/2 du. Oops. And again, we may need another slide. So 1/2, 1 to 10, u to the 1/2 du. And it looks like I'm going to run out of room. It's going to be u to the 3/2 divided by 3/2, 1 to 10. Okay, hopefully you guys all have that. Okay, so then we're going to have 1/3 u to the 3/2, 1 to 10, and 1/3 10 to the 3/2 minus 1 to the 3/2, 1 to 10. So that's going to be 10 square root of 10 minus 1 over 3. This problem's really gross, but hopefully yours won't be as gross on the test. I did give you the nicer of the two. but I do believe it is the same process, or at least similar. So then now we're going to plug that harder part in with what we just found. Okay. Um, so my intuition here is telling me that doing anything with the square root is super gross and disgusting. So they want you to use the U substitution um, and go with that approach than trying to do anything else with the square root. Okay. All right. So the next one looks deceivingly easy. And it probably is easy to an extent. It's just you want to keep track of your lines, so you don't get lost anywhere. So we want to find the integral if E is closed, is the closed box, sorry. And we're going to have 0 to 4 for the x, 0 to 1 for the y, and 0 to 1 for the z. So we would have, we're going to use Fubini's theorem for triple integrals, and the problem they would like us to solve is x squared plus y squared plus z squared dv. So what we would do is, because fxyz, which is x squared plus y squared plus z squared, is continuous on E, we're going to be able to use that theorem. So we're going to go from 0 to 4, 0 to 1, 0 to 1, x squared plus y squared plus z squared, dz, dy, dx. It's important that you know what your order is. And then we're just going to solve. So 0 to 4, 0 to 1, x squared z plus y squared z plus 1/3 z cubed, 0 to 1, dy, dx. And then we can clean it up a little. And it's going to be x squared plus y squared plus 1/3 dy dx 0 to 4 x squared y plus 1/3 y cubed plus 1/3 y 0 to 1 dx. So that's going to be 0 to 4 x squared plus 2/3 dx, which would be 1/3 x cubed plus 2/3 x 0 to 4. So we would get 64 over 3 plus 8 over 3, which is 24. Right? So that's what you would want to put in your answer. All right, now for this next one, it's similar. We're going to find the triple integral. However, we have to convert the cylindrical coordinates first. Please do not put down this answer unless you worked it out. Again, I have not worked out the exam problems. I just know that they're very similar, and I really don't want anyone just writing down the answer that we're going to find for this one and going, oh, it must be the same. Please do the work. I very much would suggest that. All right, so find the triple integral. I hope this test is more feasible than the last one. I was not going to, it was not my intent to stress anyone out, so. Okay, so assume that E is the solid enclosed by the surface Z equals 0 and Z equals x squared plus y squared, whose projection onto the xy plane is the circle? X squared plus y squared equals 49. Okay, so I think you're all good at knowing what a circle looks like in this situation, and that it would have a radius of 7. So we want to use the cylindrical coordinates to describe the solid of the integration. So we know that Z is going to go from 0 to x squared plus y squared. And we know that R would go from 0 to 7. We also know that theta is going to go from 0 to 2 pi. Okay, so now we just have to compute, and hopefully we won't run out of room. And here, guys, remember, why are we going to r squared? Because of right here. Okay, they have to be in the correct system. for lack of in the correct coordinates. So it has to be r squared, not x squared plus y squared. So then r cosine theta, r sine theta, r dz, dr d theta. And at this point, you're really just getting to your answers. This would be r cubed, z cosine theta, sine theta from 0 to r squared, and then dr d theta. So then that would be 0 to 2 pi, and then it's going to be 0 to 7, and if we clean this up, we get r to the 5th power sine theta cosine theta dr d theta. And as if anyone were surprised, we're going to have to get another slide. So 0 to 2 pi, I would recommend having a lot of scratch paper when you take this test. 1/2, oh, hold on. Okay, then 0 to 2 pi, r to the 6th divided by 12, sine 2 theta, 0 to 7, d theta. Big gross number coming up. 117,649 over 12. And that's going to be a 0 to 2 pi sine 2 theta d theta, which is going to be negative 117,649 over 12 cosine 2 theta 0 to 2 pi. So the answer for this one works out to be 0. Okay. All right. Kind of losing track of what number we're on. 8. Okay. So this time, very, very similar question. This is why you have to read on your test. Use spherical coordinates to integrate f, x, y, z equal to x squared plus y squared plus z squared over the solid E between the spheres x squared plus y squared plus z squared equals 1 and x squared plus y squared plus z squared equals 36. Okay, so converting rectangular coordinates to spherical coordinates to obtain E in spherical coordinates. The two concentric spheres have, so we have a radius of 1 and we have a radius of 6. Then we would have rho between 1 and 6. In spherical coordinates, theta is unrestricted, so the region would be 0 to 2 pi. And then phi would be between, or whatever that fancy Greek letter is. All right, so then since the integrand is x squared plus y squared plus z squared equals rho, I guess. So then we would have equal to 0 to 2 pi, 0 to pi, 1 to 6. Okay, try to squeeze this all in here for you. So then that's going to be 1, 2. I'm just going to put us on a new. One, 295 over 4, 0 to 2 pi, 0 to pi. So then we would get 1295 over 4, 0 to 2 pi, negative cosine 0 to pi d theta. 1295 divided by 2. So you just end up with 1295 pi. And you want to enter it exactly like that. Do not give a decimal. That's exactly what they want. They don't want anything else. Okay, and then the last one, I think, is a total gift. It is a gift from not only me, but just the section, the chapter in general. So the last one is just finding the Jacobian. I didn't even do a triple. I just did a double. So if I were you guys, I would either save this problem for last, like I did, or you could do it first and just feel super happy about everything. I definitely feel that this should be the problem that absolutely everyone gets. All right, and you want to give your answer in exact ugly looking answer, but it will be fine. So x is equal to 2u over 5v. Y is equal to 8u minus 4v. Oh, I hate when I have this thing. Go away. Okay. So that's just going to be negative 8 over 5 times 1 over v plus 16 over 5 times u over v squared, which is going to be negative 8v plus 16u over 5v squared. And that is the answer that they want in the box. You can use the little dot for multiplication if you want. I mean, that's how they have it, but I wouldn't see why you would need it that way. Let me stop recording.